All right. Well, thank you very much for being here today. So, just in case you don't know, in this audience, I don't think this is a problem, but so this is Mr. Jenkins. I'm going to talk about the Jenkins project today. So one of the things we do in the community is a survey of users, and if you haven't done that, I'd like to encourage you to try it. But I was looking at the answers in these questions, and there are a couple of numbers that really caught my eyes. So the one is that I find that the 32% of the people who responded had no build slaves, meaning they do all the builds on the single master instance. On the other hand, in the same survey, the 18% of people said they have more than 50 slaves hooked up under the single master. So that's a stark divide. I almost think of it as sort of like the distributed build divide. There's many people who don't seem to do any real distributed build at all, like 1/3 of the people. But then like 1/5 of the people seems to be doing quite a lot of distributed builds. And I think this used to be okay, but nowadays anyone can get a massive amount of computers to their will. I mean, and it doesn't really cost anything to do that. So in this century or in coming days, it becomes more increasingly important to be able to drive a lot of computers and then drive that for your productivity gain. So what I wanted to talk about today is sort of how I saw the sort of evolution of this runtime environment and how the evolution of the build environment and where it takes us. So this was actually my Jenkins instance around 2006. Like I started in the unused desktop that I had under my desk. I suspect many of the installations that you had might have started this way. And quickly I discovered that the single machine just doesn't have enough horsepower to keep things going. So this was a pretty good machine. Sun produces good machines, yes. So I hate that they went down the tube. But at one point, I was running like 6 concurrent builds and tests on one box, and they were just getting too slow to get the fast enough feedbacks. So one Christmas evening, I spent hacking time and make Jenkins basically distributed capable. So now I could control multiple machines. So I got a couple of machines that snatched up from people who are not also using them, and then just start to become like a cluster. And I kept adding to it, and then so pretty soon I had enough computers. Going from 1 to 2 was harder. Going from 2 to 3 to 4 was relatively easy. So that actually drives me to the first point, but that is, if you start really doing continuous builds and continuous testing, one of the very basic steps of automation and continuous delivery, you should be seeing enough workload that goes beyond a single machine. You need like a big truck to carry all the load. And again, the single machine is just not cost effective to do so. So that is obviously one reason why you need to be doing the distributed builds. And Jenkins is good at that, so I highly recommend you to do that. And again, going from 1 to 2 is hard. It takes some work to do it. But if you cross that boundary, going from 2 to 3 to 4 and forward, it's pretty straightforward and easy. Now, if we only have more computers, there are so many more things we could do, right? We could just, again, like I said, just running builds and testing all the time should have enough workload. But also, think about all the tests that you're only running, say, nightly or every week or right before the release. Now, if you have more computers, you could run these tests more continuously, and they add up to the body. They increase the body of tests. They improve the feedback cycles. It's a good thing all along. Or some of the Jenkins users started actually testing every individual commit on its own instead of bundle them up into a bigger chunk and run them, say, every hour or every night. So by doing that, there's a greater insight into which commit has produced a problem. So as soon as a regression is detected, the Jenkins could be able to tell you exactly who needs to look into it. Again, it saves the human times doing that way. So in fact, I would argue that if you can think of ways to use computers, if say a dozen computers handed to you right now, then I think something is wrong. That there should be the computers should be able to be used like in any number. Can't say the same thing as the people. Adding people to the team isn't always helpful, but adding computers to the team should be always helpful. Now, on the other hand, the one thing you'd observe probably, and I do see that all the time, is that the required capacity of the build environment tends to be quite spiky. On the weekend, if people are taking off, then there's usually no activity in the system. Also the same thing during the night. So, as you get near up the release time, people tend to rush running all sorts of tests to run the verification, they fix the last minute regression and rerun the whole test cycle. So, when I used to run the cluster of instances at Sun, we saw the whole cluster basically light up right before the release because all the QA team now needs to run tests like by tomorrow or whatever. So it tends to need a lot of capacity. On the other hand, most of the time it's underutilized. So what we want to avoid, what many people would want to avoid, is to build up the capacity of the system so that only, I guess a few hours in a week, the whole stadium is used, and most of the other time it's completely empty and wasted resources. So if you actually build up the capacity necessary to meet with your peak load, then it goes on idle most of the other time, and you want to avoid that. So the way to fix this, I suppose, is relatively straightforward. It should be that you want the elasticity in the environment. You want to be able to get just enough amount of computers just in time so that you didn't incur the cost of the entire capacity. So that's sort of one argument for having elasticity in the build environment. Now, sort of going back to my own little cluster, so I kept on adding more machines, but I also it kept on going and going. Like at some point, I started to sneak into the lab and then started to grab the machines that's in there. There was a lot of machine that was powered off or had the name of the people attached that I know who left the company. So I was basically scavenging all these different machines and then put them into the cluster, and this kept on going and going. And if you think about why I had to do this, I think one of the reasons was not just the capacity, but the fact that we need multiple different environments to be able to run tests. I think many people, perhaps if you're developing package software, you'd be probably familiar with the idea that you need to test your software, or say on both Windows and Linux. If you're developing a web application, you probably need like OS X and Windows to be able to run the browser-based testing that only runs on these environments. So for various reasons, oftentimes you need a lot of different environments. And I had some configuration, the part of the BU that I was in Sun was producing a package software, and we had this list of environments that we were supposed to run. So the part of testing involves, say, having a very specific Red Hat Enterprise Linux versions that's intentionally kept to run an old version because that's the minimum required version we have to support, and we have to babysit these environments. So as you can imagine that when you have to keep these multiple environments around, when each of the environment has unpredictable spiky workload, this capacity planning problem gets even worse. Because you can't really tell what machines would be needed at what point, and you cannot really easily convert one kind of built machine into another. So it tends to make the problem even worse. Now, one solution to the problem that people seems to have come up with, and again, I've seen this deployed, and it works in some cases, but it tends to break down, is that, for example, you could have one physical computer running a hypervisor of a sort, maybe VMware, and then they have all these individual test environment running as a virtual machine. So it turns out that at any point in time, only one thing can be run effectively, or a few things. If you actually try to run all the tests at the same time, it tends to break down a lot. So you certainly don't want to oversubscribe the hardware to have the diversity of the environment. So that again sort of calls for the elasticity here. That you want just enough computers, enough amount of computers also of the specific kind. So the fact that you have these things nicely virtualized is good, but you can do better by having an ability to start and stop and create and destroy at will. And again, Jenkins has the ability to do these kind of things. So now I keep going back to my little cluster that I used to run. So I became basically the guy who managed our Jenkins instance for our group. And then so when I look back, one of the things that I had to spend time often is that like somebody who's knock on my office door and then basically says, hey Kosuke, my bills are breaking, and can you take a look? And then so I have to look into what's going on. And sometimes, right, it's really silly problems, like the people just not getting the idea that, right, so this mentality that, well, it works on my machine, it fails on the QA environment, therefore it's the QA environment is wrong mentality. So there's some of that, but actually oftentimes there's a lot more interesting subtle issues going on. So like in one of those investigations, in one of these cases where I had to go hunt down why things are running wrong, it turns out that one of the tests that we are running was assuming that the server to be tested is running on port 8080. Because this just so happened to be a common port for running Tomcat. I guess that's what it is. And then unfortunately, the test script was written to launch this Tomcat instance, but it wasn't actually checking if the Tomcat had successfully stored it. And then so what happens is, if it just so happens that another test runs on the same box at the same time, and then that's using port 8080, and then this test kind of tries to run, but it sort of fails miserably because it's really not running the server that it's supposed to be running. So, so these things sort of is very hard to catch in the actual people's, like, the laptops, because when they run the tests, they sort of know that these constraint in the environment exists. And then it only becomes a problem when another test that also uses this port just so happens to run on the same box, which is rare. Well, let's take another case. Again, another guy come up at my door and then tells me that, look, my bills are fading. Like, can you take a look at what's going on? Well, and then, for example, in another case, it turns out that if someone had a cleanup script, so if the test fails at the end, or a test succeeds or fails at the very end, they need to shut down all the servers that they launched into the background during the test. So this script has a code to basically look for all the Tomcat processes in the same box and just kill them all. So again, you can imagine if another test happens to be running in the same box, whoa, the server is gone. And then, so if you look at that, you expect, well, maybe there's some interesting race condition going on, or maybe it's like an out-of-memory error. The guy, the people around me was reasonably competent, so like they think about all these creative, clever scenarios, and then scratch their heads. So I have to tell you that it took a lot of time for me to actually figure out what's going on. So, the moment I discovered that line, I felt like choking the guy who wrote it. But these are actually the real issues. And then I think when I think of these issues, like by stepping back at time, I think the real lesson is that a real lesson is not that the people are writing stupid script. I think the real problem is that we need to treat these builds and tests as somewhat untrusted things. You don't want to sort of waste anyone's time by sort of making them a good behaving test or a build. I mean, these guys had hard enough job to actually write functional program. So as the infrastructure, as a guy who manages the infrastructure of Jenkins, what you really want to provide is the good isolation between what's going on in your cluster. So I think this is one of the hard-earned lesson in the Jenkins community, that is the sort of one of the taken best practices, which is to try not to run multiple things in the same system at the same time. So unfortunately, this idea of providing a better isolation is kind of at odds with the trend in the computing where more computing power comes in the shape of larger multi-core big systems as opposed to single processor fast box. Right? So, given that our machines has lots of cores and CPUs in it, we want to be able to actually run lots of things on the same box. So there's a challenge in here, and then people have been trying a number of different things. So, one of the easy approach that I think kind of has its own benefit is to run the entire x86 simulated virtual machines. Right? So you run individual operating system inside it, and then so that's fine. But because you are now running different copies of the operating system in the same box, that has a higher overhead. Now, on the other end of the extreme, that is sort of the minimum overhead and creating isolations, some people have deployed multiple Jenkins slaves on the same box just by using different user accounts. So the operating system provides certain degree of isolations, like that situation, the PQ-F Tomcat, that wouldn't now, so that it's protected against that kind of thing. So that's a progress. On the other hand, there are still system-wide resources like TCP/IP port 8080. Those things would still get conflicted. And I think there's an interesting, the third option, I think, is an emerging space that I think is quite promising, is to use these, what I call as kernel containers. It's on Linux, it's called Linux contain LXC, or I think nowadays Docker is a popular environment. On different other operating systems, there are similar mechanisms like jails and these Solaris zones and so on. So these, I think the importance of providing this kind of isolation in the build environment, I think is becoming more important, and it cannot be understated. Now, so, but as I find out this, the hard way, it turns out that providing this kind of like a spatial isolation, to isolate things that's happening at the same time to different things, was not enough to solve all the problems, because I kept on having people knocking on my door to look into my build failure, right? So one more guy just show up, and then look, my builds are failing, like, okay, all right, so what's that this time? Well, it turns out that so this one also is another one that really took me a long time, and this gets a little bit technical. So I hope I can explain this easily enough. But so we are using Maven, and so the Maven it's a build system, and it comes with a mechanism to download programs from the internet, like a dependency libraries. Right? So that's a part of the selling point of Maven. And the way Maven, you tell Maven which library to download, it's called Maven sort of ID. There's like a number of identifiers, a series of identifiers that you give it to. And for unfortunate reasons, that goes because of the legal restrictions and so on and whatnot, it turns out that there are two different jar files, the binaries, are posted under the exact same ID in two different repositories. And then, so the Maven has this implicit assumption that that is not allowed. I mean, the ID, the point is that it is unique. So the fact that the single ID is pointing to different binaries fundamentally incompatible with Maven. But because those things are posted in two different places, no one knew. And also, unfortunately, in this place, it turned out that the different projects are designating different places as the place to download the jar files. So what was happening is that one project was picking up this jar file from that place, the another project from that location. So depending on which one runs first, you end up picking one, not the other. And then these two versions, two different flavors of the same file was different enough that it was enough to cause the test failures on the other project. And to make these things more mysterious, the developer of this environment has this cleanup script, because once it downloads things locally, it gets cached on the machine and stays there forever. So which tends to cause other problems. So the guy had this like a script that periodically clean up the local cache. So the end result is like, right after this cleanup would happen, one of these jobs should run, and then that basically decides the fate of the successive runs. And again, this is the kind of issue that takes a lot of time to debug. So that was another painful experience. Let me give you another example of the build failure that I actually saw in the environment, where it turns out that the test script had failed to correctly clean up the process. So PQ-F Tomcat is bad, but at least it kills everything. Now, if you try to be careful, you could end up not killing these background processes. And so these things lie around, and then it's wasting memory and so on. So slowly, the slave would start to develop lots of CLUDs like that. and then eventually sort of stop running tests in meaningful fashion, like it takes too long, that sort of things. So the lesson that I'm trying to tell you is it turns out that the isolation in the time dimension is also quite useful. So if you look at the, so I think the typical way the build machines are managed is like you get them from your IT people and you set them up and you try to maintain them, right? But just like human beings, like if you try to live too long, like things start to break down and eventually you're going to die. The same thing happened to computer. I think the people using Windows have this feeling, right? Like, every once in a while you feel like, oh, I need to install my Windows. And then so that's the same thing. In contrast, if you could actually get the machine, use it, and then throw them away, and then bring up the new one, use it for a while, and then throw them away, you could kind of sidestep around lots of these maintenance problems. So that notion of being able to throw away computers and provision new ones quickly, that sort of is again another sort of case for the elasticity. If you have an elastic build environment, this is part of what you do, and then therefore you don't have to sort of keep babysitting these environments. You don't have to sort of go to the hospital, take your computer to the hospital to make it healthy. You just like kill him and bring in a new guy. Now, when I combine this analogy with slave, I'm getting to dangerous places. So I don't want to. So that's the problem of being politically correct in the United States. But one of the companies that made a strong impression on me, we are having an event called Jenkins Scalability Summit that the Black Diamond has also sponsored back in California. And then in this event, we had a number of large users coming to the room, and they were talking about the challenges they see and so on. So in one part of it, everyone basically talked about, well, this is how we maintain our cluster of like 1,700 slave nodes, and they have all the elaborate statistical analysis and so on. And then so one of the people there was Netflix guys, and so they said, oh, we don't really have any sophisticated monitoring mechanism because once we detected that the problem is there, we just like throw away these machines and provision new ones. These guys run the entire operation on EC2, so it's kind of baked into their DNA not to sort of hold on to these things for too long. So I think nowadays everyone could do this, that everyone can create elastic build environment, maybe not on EC2, but certainly inside your company firewall as well. So that, in my mind, creates this sort of like a ladder to cloud, if you may. The evolution, the path of the evolution for the Jenkins installation, which is that you start from the single master that's doing build. That's how everyone starts. But then you quickly realize that you need multiple machines to drive the workload. But for all the reasons I mentioned, I think it makes a lot of sense to then move on to the elastic build environment where you could create and then destroy the slaves at will. So that's what I wanted to basically, it's a key thing I wanted to get to. And then if you have elastic build environment, aside from these obvious sort of like administrative benefits, there's also, you could also turn that into a lot of values that's visible to the developers or the people running tests. So one of the plugins that we wrote in the Jenkins community recently is the ability to run tests in parallel. So most of the tests that you write, I suspect, are actually fairly independent from each other. It's just that there are so many of them that if you run them all like one by one, it takes so much time. This project that I was involved at Sun, the whole test cycle could actually take weeks to run if you really run the whole thing. But since most of them are independent, it seems like an obvious idea to split them up into smaller chunks of roughly the same size. And if you think about it, the Jenkins is capable of doing it because it has run your tests before. So it had some ideas about how long your tests normally take. So Jenkins could now look at these past test reports, try to figure out like how to divide them up into roughly equal size, and then you could sort of let like 3 things run in parallel, each one running the subset of tests. So the only thing your build script or the test script needs to provide is an ability to run a subset of tests, which I think any test framework worth a dime has that feature already. So it's relatively minor addition. Like just by exposing that functionality to your test script, you can let Jenkins drive these things and then vastly decrease the time it takes to complete the whole cycle. So again, this kind of thing is really only possible you have an elastic enough build environment that can sort of adjust to the workload. And we are talking to one of the Jenkins users who were doing something similar, and they said, we divide every test into 5-minute chunk. And then if you add those, like the time it takes to start the environment and shut down and all that, every test unit runs in 10 minutes. And then on the day that I was talking to him, she said, well, right now, so that creates about 26 split. So he's running the test in 26 parallel ways and then get the results in 10 minutes. Now, if you try to run it all in sequentially, it's going to take like 2 hours. And as a developer who would be working in that project, being able to get the whole test run in 10 minutes versus 2 hours create a significant difference in the sort of the agility of the developers. So that's the kind of thing you can do if you have good elasticity. And so these are open source Jenkins work, but the CloudBees also provide this like a commercially supported version of Jenkins called Jenkins Enterprise by CloudBees. And we have some features in it that could really take advantage of elasticity in the build environment. So one of my favorite features in this space is called validated merge. The idea is, so this works with Git version control system that supports distributed version control. I mean, it is a distributed version control system. So in this, we made Jenkins speak the Git server protocol. So the developer who creates a new commit could then send that commit into Jenkins instead of sending it to the team repository. So in this way, the Jenkins would now test the submitted changes, make sure that they actually pass all the tests and whatever other criteria. Perhaps you might have the other criteria like the code coverage must stay above certain threshold. Whatever your process demands, you could set these things up in Jenkins. And then only after Jenkins deemed the build successful, the Jenkins would then turn around and push these changes to the real team repository. So with this kind of workflow, now everyone could push the changes into the Jenkins and get the test run in there as opposed to run things on their own local computer. So the developer gets more productive, and then it also prevents the problematic regressions from landing in the team repository. So it's doubly beneficial in this fashion. So these are just a few things you can do if you have elasticity. So just to I guess reiterate the point, as an administrator of the infrastructure, there are many reasons you want elasticity in the environment. The fact that you get the just-in-time capacity, or the fact that you can create the diversity of the environment without overhead, or you can isolate every build so as not to spend hours after hours isolating problems and figuring out the cause. And for developers, there's also a productivity gain that's only possible by having reasonable the elastic build environment, like the ability to do parallel testings, the validated merge. I didn't touch on the third one, but for example, if you have enough machines to throw out the program, like say the test seems to be failing in an interesting way on the continuous integration server, but I can't really figure out what's going on just from the log files. So there's another plugin that allows you to keep those machines on the side so that you can log in and look into it while the Jenkins would use other machines for running tests. So there's all sorts of interesting things that's enabled only once you have this kind of capability. And then so how do we, I kept mentioning that the Jenkins has support for these things. Well, how do you actually create elastic build environments? Well, so to start with, there's a number of solid open source plugins in this space that a lot of people rely on. So for people who are, who could use EC2, there's a very widely used EC2 plugin that basically, Jenkins should figure out what kind of machines it needs to instantiate, and then it will create a new machine for you and then throw them away when you're not using. There's a lot of additional features like spot instance usage so that you could get the slave a lot more cheaper than the official prices. But for the other, for many enterprise, if you have the sort of so-called like a private cloud, like the OpenStack deployment or the CloudStack deployment, there exists another plugin called JClouds plugin, which is a bit unfortunate name because it's like, if you just hear the name JClouds plugin, you don't need to, it's the name of the library that they use, but you don't really care what library it's using. You care about the functionality. But anyways, so this plugin actually allows you to talk to a wide range of different backends, and basically does the same thing as the EC2 plugin does. So it makes Jenkins capable of grabbing the slave by starting a new virtual machine, and then taking it and releasing it. So the another feature in JClouds plugin that we need to port back to EC2 is this, like a use of the one-time. It's the functionality to keep slave just for one build. So if you set the slave to just do one build, Jenkins will grab the build, grab the machine rather, run just one thing, and then throw it away. So it's a really, in a way, so it's the sort of extreme of the elasticity in that you have the maximum isolation between every build. So it's not only useful for the isolation reason, but also for the security reasons. And then again, I mentioned about the Jenkins Enterprise by CloudBees, and this is also, we have another plugin in this area. So we saw that a lot of people seem to be using VMware, so we developed a specific integration against the VMware. So the interesting thing about the VMware that, for example, the Amazon doesn't do is the ability to take a snapshot of a running program and easily bring back the state of the computer to that golden state. So if you think about maintaining an environment cleanly, this is actually quite a handy feature. You take a snapshot after carefully creating the environment to your liking, and then you run the build, and it sort of creates like the garbage and dust. It litters the file system, right? And then all you have to do is to roll back to the previous snapshot, and everything is thrown away, and you're back to the clean state. So this plugin could automatically control these things, and it also understands that these slaves are on the same box, same hypervisor, so it tries to schedule things accordingly. It could also power on and power off the machines automatically to avoid the loads, and all sorts of things like that, which makes this functionality quite useful. But personally, so these are sort of like solutions based on the general purpose. Yeah. Yeah. So. Yes. So it's very much possible to write the custom plugins to talk to your own internal sort of cloud API, so to speak. So, and in fact, just look at those EC2 plugin or JClouds plugin, and you can basically start by copy-pasting it, and then just change the where it talks the EC2 API, you change it to your own. So it's very easy to come up with your own too. But so these are all sort of like a general purpose solutions based on what's ready and available. But at CloudBees, one of the things we do is a hosted Jenkins as a service. So we run maybe 1,000 of Jenkins masters, and then in the Elastic environment. So we could actually spend some time and the resources into creating a great slave virtualization environment. And it's probably not true for many of you, but we could do it. So that's actually what we did, and it's called Dimension. And this is one of the technologies that runs behind our hosted Jenkins as a service, aka Deva Cloud. So the basic idea is the same. Like you have one box, one system. We call that mansion that houses multiple slaves. But we use the kernel container technology called Linux containers to virtualize the individual tenants. So at any point in time, we might be running multiple different users builds on the same box for performance reasons. But and then they all run on the same single kernel. But from the point of view of individual processes, they get to only see small sections around it. So one guy might be running some Maven build in Git. Another guy might be doing some Ant build and so on. Maybe the third guy is building an Android application on Gradle. But each one thinks they are the only thing that's running the system. They have no idea what else is going on. But because they are running on the same kernel, we could sort of share the same sort of page caches or file caches. It sort of not only isolate them, but it actually boosts their build performance to a certain extent. When we run another operating system, like we recently started supporting the OS X as a build environment, well, we actually have to emulate a lot more. So for example, the very fact that we could emulate OS X execution is an achievement on its own. But in these cases, we have to patch the kernel and run it over QEMU. So the cost of virtualization is somewhat higher than the case of the Linux slaves. But that didn't prevent us from trying to be as efficient as possible. So for example, in this mansion, we used the technique called as a kernel same page merging. So if you look at these 3 OS X instances that we are running, they're actually loading the exact same version of kernel, same set of drivers, lots of similarity between these environments. So what we can do is if you actually look at the individual memory page that constitute OS X, you could find a lot of same pages. So what the system allowed us to do is we'll find them and then only keep one copy of them and then throw away the duplicate. So that allows us to significantly save the memory overhead, and only the different things needs to be kept at the individual virtual machines. So it's still a lot more efficient than, say, running this inside the VMware, I believe. And then that's just about the CPU isolation and the CPU emulation. There's a lot of innovation that we put into the file system layer as well. So this is where we use the ZFS on Linux, which is something I really wanted to do, which is to use the Sun technology. ZFS came originally from Solaris, so it's quite ironic that as a former Sun employee, I only get to use this technology after I stopped using Solaris. But now I feel complete now that I did it. So there's many features that this drives that turns into tangible benefits for people. So for example, you want to isolate these different builds, like I said. So one feature in the ZFS is you could very cheaply create lots of file system without committing to the size of the file system staging early on. So we can keep them all around inside this a set of large, a pair of the SSD disks and so on. And then only when the build happens, we can expose them to the right slave. So it's secure, and it also creates isolation. But it also provides the sort of like a previously built workspace. So every build now can be incremental. It has a great benefit on the speed. Or I was talking about elasticity, where we might be running the same test on 28 different environments at the same time. Right? So in that kind of context, we could use another feature in ZFS, because ZFS is what's known as a copy-on-write technology. So we could instantly create the identical clone of the same workspace, as many as we want, and then assign them to individual slaves that's running the system. And then so when they read the same data, it's reading the underlying data, so it's very efficient. And as they write them, they produce the mutations. They keep the mutation in their own file system. So not only, for example, it benefits from the shared file cache, but it also benefits from a far reduced disk usage. And then this is a real copy and write, not like a UnionFS crap. So this is a lot better in that regard. And then we can use this for all sorts of other reasons. So for example, for people doing Maven builds, that there's this notion of local Maven repository that's effectively a cache, right? That every build needs. And then Maven spends a lot of time downloading it. If you're forcing it to download it, and then so we have this ongoing joke that the Maven tends to download the internet, in which we mean like it downloads like a 50 megabyte of dependency just to compile 3 source files. So now with this kind of copy on write file system, you could have one master copy of the Maven repository, and you could clone them and assign them to individual workspace. So the chances get drastically higher that you have a lot warmer workspace, the warmer cache. So in most of your build, it goes quite smoothly. And you only need to download little things here and there that's not in the original cache file system. So these are the things that the infrastructure can do to make the engineers even more productive. So that's a few of the things the CloudBees is doing in this space. Now, what I talked about is Dev@ Cloud. It's a hosted environment, and we are trying to work on opening this up to the consumption from your internal Jenkins master usage. Right? But the CloudBees also does another thing in this space that might be useful. It's called the Jenkins Operations Center by CloudBees that we released last December. So among other things, one of the things this does is it adds a layer that controls multiple Jenkins instances. And then you could basically pool the build machines at this operation center. And then operation center communicate with individual masters in your environment. And then they would basically lease and return the build saves on demand. So you can have these set of masters sharing the same set of build machines and then create sort of like a semi-elastic feeding to the individual build masters and share the build resources. So that's the kind of, if you get to this kind of elastic build environment, that's definitely a milestone. And it's sort of, you'd feel like you've reached a new level of mental peace or the new level of enlightenment. Well, so all is good. Well, the job is well done. Let's pack home, and then let's head home, or is it? So it turns out that this story doesn't quite end there. As you start sort of embracing this idea of what elasticity can do for you, it turns out that to really be able to derive lots of workload in an elastic manner, you actually also need elastic test environments. Because the bulk of the interesting things that you run on Jenkins is actually testing related, right? Testing things after running applications, testing things in different modes with different browsers, that sort of thing. So to really sort of take the elasticity in the logical conclusion, you have this same sort of problem on the test environment. So the traditional attack vector to be able to test, have an elastic test environment, well, it's just to sort of divide things up enough so that the individual PCs doesn't have any like a locational dependency to test, or AKA the unit testing. So we kind of hope that we test individual small pieces at a time, and then hope that when they are put together, they are still functional. And so there's nothing wrong with unit testing. It's great. We do this a lot in Jenkins and also in CloudBees. And it runs fast. It runs anywhere. It runs on people's desktop under the debugger. It's all great. But there's also it's sort of the fact that we tend to do testing that way is because the testing, the sort of software as a whole or the system as a whole is still incredibly hard. And especially in the connected world where the application that one team might be working on might involve talking to different services or multiple PCs that's running on different machines, being able to test them is really hard. You got the database that you need to talk to, you got the load balancer that the production environment is running. And then sometimes, well, these things does make a difference in the behavior. Or you might have some identity services that you need to log in. Well, that makes your testing harder. Right? So there's really, I think, only two ways to do this kind of thing. One is to substitute use lesser things. Okay, so this kind of looks like your familiar product, but like if you look at the label, it's like a totally bogus. Or you create the mock, right? So so this is so the people doing civil engineering go to extreme to create mocks. This is for simulating earthquakes and how that affects the building behaviors. So they spent a lot of effort, and then as you can see, sort of creating these like a proper integration, like a large-scale testing involves a lot of work. So people tend to do it less often. In Jenkins and CloudBees, certainly we do both. We do both of these. We run bulk of the tests on Jetty, so we sort of substitute the real production web containers that we're using with one. That's AKA Jetty. That's easy to automate. Instead of trying to test with the real authentication database, we have a mock implementation that we could use for the purpose of testing. So sometimes it's just a major accomplishment just to be able to create a mock, right? So the Subversion plugin is tested by driving the real Subversion server, but the Subversion server doesn't really like to be created 5 times every minute or so. So we had to sort of do some real work to make it behave, and so that's the kind of things that sort of drag us down. And then my worst arch nemesis in this space is like the Active Directory that still refuses to be mocked, and I have to have a dedicated virtual machine that runs Active Directory just so that I can run the test for the Active Directory plugin. So it's all quite painful. Now, in the ideal world, well, so you want to be able to test the software in the real environment. So if you think about that kind of context, there really is no difference between the test environment and production environment. It's ideally identical, But that means, but in practice that's often hard because it involves automating so many pieces of the infrastructure, and we are not quite there yet. Although at the same time, I think this is sort of the emerging area that nowadays a lot of people are spending efforts on. So, for example, the part of the challenge is what's otherwise called as infrastructure as a code. Right? So, say take a load balancer in the previous slide as an example. Well, using Chef or Puppet to lay down the HA proxy, say the open source, the load balancer, and putting down a certain configuration, that's sort of, it's nowadays a well understood problem. So you can do that, and people see the value in doing this. So we are definitely marching in this direction. But to actually bring in the real challenge, I think that I don't think we have really yet addressed adequately in many of these tools, is the fact that we also need them to be elastic. So not only the ability to lay down the HA proxy is important, but the fact that we can grab the box that runs HA proxy in, I think that's still really hard. I mean, the Chef and Puppet certainly doesn't really do those things on its own. And then, individual piece is hard enough, but if you have all this cluster of related systems, like you have to have one database, one HA proxy, like 3 copies of MongoDB running, and then 2 Tomcat running. That's sort of set up that talking to each other, creating the entire environment rapidly and destroying them on the wheel is really painful. So I think that's sort of, but if you think about the value that elasticity brings, if you can instantly create the environment just to be able to run the test in, it's the exact same environment as in production and throw them away, you could imagine how much productivity gain that it brings. So I see a very similar sort of ladder of evolution to the runtime environment as well. In the good old days, we only had one environment, aka production. And in some system that I maintain, I still test in production. Like I deploy, and if it doesn't work, I quickly fix it and bring it back. But then quickly, I think the people do realize that you do want to have multiple statically maintained copies of the environment, like often called as maybe production and QA and testing or sandbox or that sort of things. Carefully maintained fixed number of copies of the environment so that you could at least do tests in them. But if you think about what happened in the build environment and then why you had to have elasticity, the same thing is also applying in the runtime environment as well. I think it's the only logical that we want to have the ability to rapidly create and destroy them. And if you think about this ability to create and destroy all these pieces, I think that is sort of almost by definition, it's a pass. So that's the other thing that the CloudBees does. And so nowadays, what I think of the CloudBees as, I think that's sort of so I see great parallel in it. And hopefully what I was trying to do is to get the point across that the benefit that the elastic build environment would bring you, and just think about the implication of that, what it takes, what happens if you take it to the logical conclusion to your runtime and test environment. So that's what I wanted to pass along, and thank you very much for listening.